Better go get it. Okay. So, it's a brand new unit. For those of you that did not do well on the exam, maybe this one you will do a study sheet and do your homework, and because we're going to be doing more of it. Can you shut the door now? Now, today we're going to be going over and really emphasizing these three words: zeros, roots, and X-intercepts. Now, why are they important? Because zeros equal roots equal X-intercepts. They are synonyms. Whenever you hear one, you should think of the other two. Okay? So one question will ask for the zeros. If the next question asks for the X-intercepts, okay, you should be going, hey, that's the same kind of question. They're just seeing if I know. Okay? So that's the first. We're going to get to that. But we just want to review that these are going to be functions. Does anybody remember from last year what a function is? No one? You remember the word? What was that thing that you could do to see if it passed, if it was a function? The domain is the same as the range? No. Remember how you drew that line? Do you remember drawing that line? Just need to move up here. Remember the vertical line test? Do you remember that? Now, here's what a function is. You guys need to move your rows up so there's no empty desks in front of you. A function is, read along with me right here. Function relation or function is a special type of relation in which each element of the domain is related to exactly one element of the range. Okay?
Good morning, Edmonton Christian. Here are your morning announcements.
Okay, so as I was saying here, for every x, there is only one y. Okay? Now, this gets confusing to people when this stuff kind of happens. When you'll have your x's and then your y's, right? So, remember they always go like this. So if I had 2, 3, okay, can I have 4, 3? Is that a function? Why is that a function? X has 2 different y's. There are any x's with 2 different y's. Good. Now that gets confusing to some students. They're like, I don't know. Now if you graph this even, so can you picture this as a graph? So there is 2, 3, say that point is right there, and then 4, 3. Now would that pass the vertical line test? Yes, it would. Okay. Now, so this is a function. Now, if I just had one of those on the test, and I did this, I'm going to get some people that say that's not a function. Because they are getting, they said, well, Mr. Truman, you said for only x there can be one y. But look, those y's are both the same. Okay? Now, if I had, okay, so another scenario. If I had 2, 3, and 2, 5. See, that's 1x giving two different y's. Do you see that? So if we were to graph that even, we would have 2, 3 here, and then 2, 5 here. Now, would that fail the vertical line test? Okay. Now, so that is the BLT. Remember the vertical line test, and this is not a function. Now, even going through this, there's probably, I would guess, around 5 people in here that still don't get what this function thing is. Now, a function is, like, can you deal with equations that are not functions and stuff? Yeah, of course you can. But we're just dealing with functions, and you're like, well, I don't even get like what's going on, right? So here's an example that I made up for students that still aren't really getting the concept. Now, can you go, to the confectionery or whatever and read the sign, right? And it might say like this. It might say hot dog, $2. Okay? Now, this is a relation, right? X's will be what it is, and Y's will be what's the outcome, what comes out, okay? So even in my computer, I have all of your names. That would be the X. And then your marks are right beside your name. Those are the Y's. That's what came out. Like, you provided the Y's. Okay? Now, there's hot dog, $2, and hamburger, $2. Now, does that make sense? Can two different things be the same price? If you were a 5-year-old kid, you'd be like, okay, they're both $2. No big deal. Okay? See, that if it makes sense, then it's a function. Okay? Now, right away, I still have people going, yeah, where are you going with this? Okay? Well, let's do another example. Okay? If I had hot dog, $2, and then I had hamburger, $2, and then I had hot dog, $3. Now, to a 5-year-old kid, this should be very confusing. Like, what? There's got to be some mistake. That must be like, there must be chili on that one or something, because it's more money. Okay? But the guy goes, no, same hot dog. Could you do this? Like, you're not going to go to jail if you did that. But it's not a function. It's 1x giving two different y's. Do you see that? Okay, so this is probably the simplest way I can explain the difference between a function and not a function. Is 1x giving two different y's. But different x's can give the same y's. Does that make sense? Because you could have 10 things on there that equal $2. That's okay. That makes sense to people. They're all right with that. But when you have the same things equaling different money, people aren't happy with that. They're kind of ask you a few questions. So, does this kind of make a bit more sense now? What a function is and what's not a function. Because obviously it is pretty important concept. Now we're going to get to a really important concept. So let's go to page 293. Okay. Now, let's solve this. So I want you to write this down. X squared minus x minus 6 equals 0. Now I'm looking for two things that that add to give me -1 and multiply to give me -6. Now, how have I taught you to do these ones? Anyone remember? Huh? Right. So what am I looking for first? The signs. Okay? Now, obviously you don't have to put up your hand, but how many people ignored that yesterday? Because you got your signs mixed up. Why? Didn't do them first. Okay? And it's hard when I'm marking that and going, like, why are they throwing away marks like that? They were even allowed to use a study sheet. It should have said on their study sheet, do signs first, right? And some people, you can tell them over and over and over again, they still won't do it, okay? There's on the news today, the police did a check stop on distracted driving, and it's horrible. In the other provinces, they're more strict. I think it's $240 here. In other, you get 2 demerits. Now, demerits are ugly. So you get like $270 and 2 or 3 demerits if you get caught if you're texting while you're driving or whatever. Okay? Do you know that there is some people that say their buddy just got it? There's some people that would actually say this in their head. That wouldn't happen to me. I won't get caught texting. And they're not saying, I won't text. They will say, I won't get caught texting. And we all know those people, right? They are the ones that get impaired driving. Their best friend could get impaired driving. They could lose their license, and they, you know, now they actually lose their job because their job they had to drive. And they're like, oh, that sucks. But you know what? I can drink and drive, and it won't happen to me, right? There are those people. Okay? There's kids that you could tell if you touch that stove, it is gonna burn like you wouldn't believe. There's some people that still have to go touch it. Okay? And you know the people I said, make sure you always do your signs first or bad things will happen. That was like, yeah, I don't have to. That's the next guy. That's not me. Okay? Because a lot of you lost marks just because you didn't even do the signs right. Now, what are the signs? A negative and a positive. Okay, and the first number should be the bigger of them because it wins, right? And what would those two numbers be? 3 and 2. So this is x minus 3, x plus 2. Therefore, what are the zeros? 3 and -2. Very good. Now, if you graph that, you get this thing right here. Now, what are the x-intercepts of it? 3 and -2. Now, so if you made this thing equal 0, which I actually did, when we solved it, what do you think the zeros would be? 3 and -2. So do you see that roots equal x-intercepts equal zeros? Now, here's one thing that some of you guys are going to get confused on. Do you see these numbers here? Look at them. Do you see the little thing going around them? Like a little bee? See those? Are these the same thing as these? No, they are not. Are some of you going to, it's going to ask for the roots, and you're going to find these two numbers, and you're going to write down the two roots are -3 and 2? Now, did I just tell everybody, don't do that? Go here, write down x minus 3, x plus 2, and then go find the zeros. The zeros will be the same as here. Now, even though I told people, the people that will not write it on their study sheet, there are people that will, because they're trying to be quick, right? They're trying to be fast. So they're going right here. They're getting the multiple choice done. Look how quick they were. That's awesome. Like, they got it wrong. But look how fast they were. Isn't that cool? Okay. There's nothing better than being the first one done your exam and like handing in and like walking out. Like, you look so cool in front of everybody, right? And those are really quick to mark usually because none of the written response are done. So take your time to remember that when you find these, those are not the answers. Those are your factors that you found here. The zeros are what you're looking for here. Now, and someone in the last class was just able to see this. Is there anything else really significant about that graph that I should point out? Look at the picture. We will actually worry about that more later. That's max and min. We're going to talk about max. This is a minimum, right? There's a minimum right here. You see, there's no point lower than it on the graph. That'd be a minimum, okay? So that's good. We will talk about the minimum later, okay? Any other point on there? Any other thing that the slope? We will talk about that later too. It's called the stretch factor. Yep. What y's are the same? The x's are the same, right? We already talked about that. Come on. What else do you see in there? Yeah. Yeah, but what do you think it is by looking at it? -6. That's pretty significant. Did you get that from the equation? How? Make what? Make x equal 0. Why make x equal 0? Like, what is x here? 0. So if I took my equation, x minus 3 times x plus 2, and I make x equals 0. Well, let's do that. 0 minus 3 times 0 plus 2. That's the same thing as -3 times 2. That equals -6. So right from your equation, you should be able to find out what are my x-intercepts, y-intercept. You will later talk about slope. Actually, slope only is for a line. We call it a stretch factor because we can stretch that thing so it's really, 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 really thin. Then we're going to be talking about max and min. Okay? Because some have maxes, some have mins. I mean, obviously this has a minimum. This doesn't have a maximum, does it? Because it goes forever up. So there's no maximum. It's infinity, but we're not even going to say that because it's kind of like a non-answer, right? So it's very, very, very important that you remember these are all the same, okay? They're synonyms, right? I can ask you for any one of those, and I'm actually asking for the same thing. The zeros are same thing as the roots, same thing as the x-intercepts. They're not the same thing as the factors, though. Okay, factors are opposite to your zeros. Okay, let's kind of see what's going on here. Let's do example 3. Okay. So let's see how we can use our calculator to get the equations. How we can look at a picture and be able to get the equation. Now, many of you, okay, you can just look at this, you don't have to do this, but many of you, if I gave you this graph right here, and I said, what would be the equation of that graph? Many people would be pretty overwhelmed and go like, what? That's impossible. How can you just look at that and say, oh, this is the graph for it? Okay? Well, in about 40 minutes, every one of you will be able to look at a graph and be able to come up with the exact equation. Okay? So you're going to take a visual and you're going to make an equation from it. So there's a lot of things that have to be going on. There's a lot of things that are going to have to fire to be able to do this. But it's a pretty cool skill. Why is it a cool skill? Because I think we all want to get 100 on our diploma. I think we'd be lying if we didn't. And it sure is nice when they say from this graph, give me the equation, and you're spending a minute and a half on it, and you can actually just look at a picture, get the equation. Then you could take your equation, graph it, see if you get that picture. Like you're going, I got that one right. Like it's the same one. I got the same X-intercept, the same Y-intercept. It's going in the same direction. I mean, I have it, okay? Now, there are many, many questions like that in the diploma, like you're like, I got it for sure. I know I have that one. Okay? And then you're going to put a check mark on your diploma, and you're going to say, you know, write something to yourself, so when you come over at the third time, you can, you know, even try something else. So my goal is when you get to the diploma, you know 3 ways to do every question. And when you've done the same question 3 different ways, and you get the same answer, and you can do that on 40 out of 50 of the questions, that's all right, okay? But it is a skill to be able to learn how to do that, okay? Now, right now, it may seem almost a burden that you've got to learn how to look at a picture and come up with an equation. That sucks. But it's not, if you know a few little things, it's a pretty cool skill to have, because now you'll be able to do some, you know, verifying with your calculator and all those sort of things. So let's just start with the equation, and we're going to work to getting the picture. Okay, now the zero feature of a calculator. Now what we want to do is we're going to learn another skill today. Let's go to our calculator and put that equation in. Okay, so can you make sure your screen has absolutely nothing on it? So look, there's nothing there. So you're going to go 2x squared minus 7x plus 3. Okay, everybody look that you have that. Okay, then I want you to hit zoom. Where's zoom? Top middle, right? And then 6. And then we should all be looking at that graph. Now, just watch before you try. Everybody look up, okay? Now, to be able to find the zeros, I'm looking for this and I'm looking for that, right? Those two, those are zeros. Zeros are the same thing as what? X-intercepts and roots. They're all the same. So to find that one, all I do, now, everyone looking up, even those people that aren't looking up right now. If I go second, calc, 0, I think it's rightly named. Now here's what you have to do. See where the spider is? You see where the 0 is? You have to get on the left side of it, and then you hit enter. Now up here's a little arrow, but you can't see it. Okay? And then I'm going to go to use my right arrow, and I'm going to get to the right of the 0, and then I'm going to hit enter. And see those two, there's 2 little arrows up there saying, okay, I'll find the 0 between those 2 spots. Okay? And then you hit enter again, and it gives you 0.5. Now, you're not doing it yet. We'll do it all together. You're just watching. Now, for those people that are like 0.5, what is that in fraction? Because decimals are our enemies for these ones. We want fractions. So to be able to get into fractions, now I know everyone's going, it's a half, I don't need to do that. But some will not be as sweet as this one. So you're going to quit, second quit. Now all you hit is X, and then press equals. Because that's the last X I ever got. So you just hit, and then hit math, enter, enter. Okay, and it'll give you the fraction. Now it's important to know that fraction. Okay? Now, let's all try to find the other one. So, we've all hit graph. So, we're going to hit second, trace, which button? 2. So don't hit 0, hit 2. Find 0. Find the word 0. Now, always get to the left of it first. See where my spider is? You can go left, right, right? Can you see that? Use your left, right one, not your up, down. So left, right. And so am I to the left of it? Yep. So hit enter. Now, if you're kind of left, right challenged, these will be hard, okay? And then now I'll get to the right of it, hit enter. And see how there's those 2 little arrows? And then hit enter again, and it'll give you the other one, 3. Now, I actually never use this 0 function. I always, always, always do this. I go y equals, and I put y2 as 0. And then guess what I use? Second, trace, intersect. Now where's my spider? Right there. And all I have to see where he is, enter, enter, enter. Now, I got this question about 5 times from the other class. So that's good. Students came up after and they're like, I can't get that other one. You know why? Because they're like trying to like go over there now. You actually have to go second, trace, 5 again. And then get the spider over by it. And then hit enter, enter, enter. Okay? So, can you draw this graph? See that little graph they gave you? You can draw it, or all you have to do is hit second, take screenshot, do black, white, LCO, and then you just come here and you just press paste. It's kind of small, so you just grab the corner and do that. Okay, everybody do that. And what are my 2 points? 1/2 and 3. Now, obviously, I know what the equation was. I put it into my calculator. But this actually does the factoring for you. Okay? So, I'm just going to write down 2 statements. X equals 1/2 and X equals 3. Are those fair statements to make? Okay? Now, I am going to solve them. Actually, I'm going to unsolve them, I should say, because they're telling me what X equals. I don't care what X equals. I want to make X equal 1/2 equals 0. So I want the right to just have a 0 from it. Now, the first thing is go minus 1/2 to both sides. And you can, but we're never going to do that. We always want to, if there is a denominator, get rid of the denominator by multiplying. Always, okay? So what would I multiply to get rid of that denominator? 2. So I will multiply a 2 and a 2 there. So do you see now I have 2x equals 1? Right? Now, how would I make this equal 0? Subtract 1 to both sides. 2x minus 1 equals 0. Okay? Now, when x equals 3, how do I make this equal 0? Subtract 3. X minus 3 equals 0. Now, and this is pretty cool, if you ask me, but this thing that I just put the box around is the same thing as 2x minus 1 times x minus 3. You see how I went 100% backwards to what we did before? With the points, I was able to find the totally factored equation. It's much faster. But this is a skill that if you don't know, you're going into a diploma with a huge disadvantage to many of the other students going in. Now, here's what you always need to test though. If you multiply, you know, FOIL, first, outer, inner, last. If you multiply the firsts, does it equal your first term here? Yes? Then always double check your last. Do these equal the last term? Yes. There's also one other thing you can get fast out of there. What's another thing you should check to make sure that is the true equation? The y-intersect. If you put zeros in there, will you get that y-intersect? What is the y-intersect? Your calculator gives you the y-intersect, and it is actually the easiest of all things to do. How do you find this thing? Right there. See, it's right there somewhere. How do I find that? Okay, all you have to do is this. Watching? Hit trace, 0, and then enter. Trace 0, enter. Now, trace 0 says trace, I'm allowed to put in any x, it'll give me the y. Do you see how we always said, what is the y-intercept when x equals 0? So, our y-intersect is 3. Does this equation give us the answer 3 if I make x equals 0? Yes, it does. That's how I know I have the right equation. Okay? So this is the right equation. 2x minus 1, x minus 3. Okay? Let's go over to example 4, and we're just going to do b. Now, if I was to graph this, what do you think the x-intercepts would be? X-intercepts are the same thing as what? Starts with a Z. Zeros. What are the zeros of this? Does anybody know one of them? Okay, so 3. No, just 3. If you put a 3 in there, it's going to make that all equal 0, won't it? That's all that matters. Negative 5 over 4. And everybody knows how to do that now, right? Hopefully, you know how to do that. When you go 4x plus 5, when does that equal 0? Minus 5, and then divide by 4, right? Negative 5/4. Here's the million-dollar question. So these are the roots, by the way. Those will also be your x-intercepts, right? What would be the y-intercept? Negative? No. Negative 15 is the common answer. Negative 90. How on earth did she get negative 90? Yeah? Multiply by 6. Now remember, to find the y-intercept, you want to make x equals 0, correct? So if I go 6 times 4 times 0 plus 5 times 0 minus 3, this is the same thing as 6 times 5 times negative 3. Right? Someone said what over here? What's wrong? What's confusing? Make x equals 0. Y-intercept is when x is 0. So I put 0 in for all the x's. Wherever there was an x, I put a 0. Where did I put the 6? Look. Yeah. That's why it's confusing. That's a nice shade of red you got going there. Okay, so 6 times 5 is... What's 6 times 5? 30 times negative 3? 90. You know what's the cool thing about when you find the roots and the y-intercept? How you know if you got it right? You graph it. Okay. Okay, let's go over here. Now, we're not going to go and factor it all out. We're just going to use the graph to find the factored equation. Okay? Now, we've done factoring already. We even wrote a test on it yesterday. So you should still know how to do that, right? You got to find what two things add to 4, what two things multiply to negative 21. Then you got to do, right? Remember that? Now, let's not do that. Let's just do it 100% by graphing. Okay? So, let's graph it. So you're going to go y equals 3x squared plus 4x minus 7. Okay? Hit zoom 6, so we're all looking at the same one. Zoom 6, yeah. Okay. Now, can you just, all you do is, right, take this screenshot, press paste, and then have your graph down here. Okay, now, what is this point right here? Who could find that point? Yell it out as soon as you get it. What's that x right there? And I do not want decimals, because decimals make this very, very difficult. We always love decimals. They're our friends. Fractions, ooh, evil little fractions. Now it's the other way around. Decimals, it's hard to work with, but fractions make it quite easy. What is that one that I got the arrow pointing at? Did anyone get it? Or is everybody just being shy? What'd you get? Good. So you write this statement down. X equals negative 7 over 3. Okay, this one here. How do you find that one? Now, you can use your y2. Hopefully put y2 as 0. Then you're going second, intersect, and then enter, enter, enter. What are you getting? You're getting 1. Now, I would always recommend you do this. Go find the y-intercept. And you'll see y in a second. Get it? Y. Okay. I don't actually have a writer. Like, I come up with these myself. What are we getting? Trace 0, enter. Negative 7. Okay. What's wrong?
Okay, so I went to zoom 6, second trace, 5, enter, enter. No. I'll trace 2, trace. Never mind.
Okay. So, x equals negative 7/3. I want to turn that into equals 0. So what's the first thing I would do? Times it by 3. Then what would I do next? Add 7. So 3x plus 7 equals 0. Now the other one. Remember? X equals 1. So what would I do? Minus 1 to both sides. So x minus 1 equals 0. So my equation is 3x plus 7 times x minus 1. Now, and you'll see later that you need to always test this. But do the first two numbers, if you multiply them, does it equal the first number on my equation? And the last two, if I multiply them, does it equal the last number? But more importantly, if I put in 0 here, do I get my y-intercept? Try it right now. For y-int, we want x to equal 0. Test it, because we know the picture. So we need to make sure our equation matches the picture. So y equals 3 times 0 plus 7 times 0 minus 1. That equals 7 times negative 1. So y-int equals negative 7. Okay, good. I got it. So that must be the equation. Y equals 3x plus 7 and x. And you know what? How do you know if you got that right? Graph it. Put it into y3 and put it, the bold. That's why these, like you should see on the last test we just wrote, right, we had a 78 average. We had a ton of people that got hundreds and 95s and 98s. And then we had too many people that got in the 30s, the 40s, and the 50s. Because if you know this stuff, there's no way you're going to make a mistake. If you still haven't kind of got the concept, so like X-Intercepts, is that the same thing as your factors? No, it's not. It's the same thing as your zeros or your roots. Okay? Now, some people, you think I'll give an exam or a quiz tomorrow and they won't check their y-intercepts? Of course. Okay? Now, get B into your calculator. So that is 4x cubed minus 7x squared minus 4x plus 7. Okay? And then we'll all hit zoom 6, so we are looking at the same picture. Now I want you to roughly draw this picture the best you can, or you just take a screenshot. Whatever you guys want, your choice. Okay, now we have some things we should be looking at. We have this, and we have this. Okay, going left to right, what are they? Negative 1, the next one, 1, and the next one, 7 over 4. Another good thing to know would be to find the y-intersect. What's the y-intersect? 7. Okay? I'm going to give you 1 minute. Come up with the equation. What would be the equation to this? Okay, some are probably done by now. And that's why the rich get richer and the ones that know it get faster, and then because they get faster, they have more time on their test to check it over. Okay, so when you see this x equals negative 1, what does that turn into? X plus 1 equals 0. Okay, now when you have x equals 1, that turns into x minus 1 equals 0. Now how about 7 over 4? 4x minus 7 equals. So your equation should be y equals x plus 1 times x minus 1 times 4x plus or minus 7 equals 0. Now, do your test. Do all three first ones, when they multiply, does it equal your first term? Does it? Okay, now your last ones. Does it equal your last term? And the most important thing, when you make x equals 0, does it give you your y-intercept? This would be 1 times negative 1 times negative 7, which does equal 7. Yes? Okay. If you put x equals 0 in here, would only the last term be standing? So when you have an equation, your last term will be your, okay? Now again, how are some people coming up with these generalizations, right? That's the mathematical thinking. It is seeing a few of them and going, hey, okay, Pythagoras took a bunch of right-angled triangles and go, you know, if you take the square root of this plus the square root of this, or square this, then takes, it gives you that hypotenuse every time, okay? Now, some people still look at that and they're like, yeah, I don't know how he figured that out. But after you do something enough, you try and find a better way, a faster way that actually works all the time. Now, you know how what I like about this book is the examples are usually it's harder than the homework. Well, there's one question that I do want to do with you as notes because these are great questions. Let's look on page 298, 6b. Now 6b is an awesome question because it just makes you have to be thinking. It kind of gives you all the evidence and says, hey, come up with what happened here. Now, just by looking at the picture, can I come up with an equation? Okay, how? Okay, this is negative 2, and what's the other one? Okay. So x equals negative 2 and x equals 4. Okay. Where do I go next? So I'm going to add 2. So x plus 2 equals 0. And the other one? X minus 4 equals 0. So your equation is y equals x plus 2 times x minus 4. That's pretty easy, right? Are we getting that concept? The only thing that's wrong with this, it's not giving me my y-intercept. If I put 0 in there right now, what does it give me? Negative 8. What is it supposed to be? Negative 16. Make this equation so it equals negative 8. Or negative 16. What can I do to it? You will put a 2 there. Okay? So, this y-intercept, which is negative 16, if you put x equals 0 here, originally, so if you put x equals 0 originally, you would just get the answer negative 8. But, so what do I have to do negative 8 to get negative 16? I've got to multiply by 2. So multiply your equation by 2. That's how we came up with this. Now, believe it or not, that's a pretty awesome skill for you to be able to look at a fraction, look at a picture, come up with the exact equation. That is something 4 hours ago or half hour ago, if I would ask anyone, come up with the equation, they would say, are you nuts? You can't just look at that and come up with an equation. I mean, let's do C. Let's do C together. What are the zeros going left to right? -2, 3, and 4. Okay? So what would my terms be? X plus 2, X minus 3, X minus 4. Okay? And then put your Y equals. Now, before you get all, yay, I got it, and go on to the next question, check if it gives, what is your Y-intercept? 24. It's going by 2's. Check if you put 0 in right now, what does it give you? It gives you 24. So you're done. See? It's not so scary anymore. And not only that, do you know that this question right here, if I just said, give you the long equation, x cubed plus 4x plus, or 4x squared plus 3x plus 2, and I said factor it, it's going to take you about 5 minutes. You just factored it using technology. Now people like to say I took you to the computer lab and I showed you all this, and you're like, oh, that's cool, that works. And then you get back into the classroom and you're like, yeah, I wish I had the computer thing to do this. You get to use that in your diploma. Okay? It is crucial that you're getting to the diploma that this is second nature. That you would just think, I'm graphing it. Okay? Because we did that question in under a minute. That was as a class, doing it slow, and that took a minute. Now, a minute's not bad. Right? And it's right. Okay? And then if I had to come up with the unfactored equation, I would just multiply all that stuff out. Yep. It depends. If it says algebraically determine, you do all the algebra. But if you knew how to do the algebra, could you still get the question wrong? Yeah, because we all make mistakes. If you knew how to do algebra and you did it, would you be able to know you got it wrong? Yes. And then you'd go back and you check it. Now again, this only works for the students that actually know what they're doing. It will not be the substitute for learning how to do things algebraically. It will be your way of checking it. And if on my exam it's 3 steps and you know how to check it, you know that you got it right. And you're walking out of the exam going, I know, yeah, I got number 3 right for sure. I graphed it and got the same one. Got the same Y-intercept too. So I got that one right. And you're going to have someone out there go, oh, I didn't even graph it. And you're just going to be like, what? Are you nuts? It's weird. There are those people. Okay? So, you can see there's some good study sheet stuff to put on here. So hopefully you get around to that. Because if you're not getting 100 on the quiz tomorrow, okay, it's got to stop, We all make little mistakes, but I got people getting 0 after 0 after 0 on these quizzes. I take these from the homework, okay? So you're telling me you did all the homework. You did a study sheet, and you're getting 0 after 0 after 0. Okay, obviously you can tell I'm not happy that we had a 78 average on the last one. And if you are getting any mistakes on your quizzes, you should be coming in at noon and fixing that. Remember, if you want to do well in school, like I'm not taking any of your time away from you after school that's busy, that's nuts. You're at school anyway. Work smarter. Come in, learn it. I'm here every single day at noon. Okay, every day. I have people, they have spares. They're like, can I do it in your room? Yep. So I have people that are on spares that'll be doing it in a different period. That's fine. You can see I have empty desks here. Okay, you get to listen to my jokes twice. This is a huge bonus. Sometimes I do use them twice, I won't lie. Okay, but you got a spare, you're at school, you can fool around in the atrium. Yeah, that's awesome. But you know what? Either you will not do it after school, your work, or you, instead of hanging around with your friends and goofing off and stuff, which you should be, your kids, you will be doing your math homework. Okay, do it in school. Okay, we're halfway done the course now. Remember I said you guys have to change. And a lot of you have. But there's some people still, they're doing the junior high thing still. Right? Seeing how little they can do and get away with it. But they're doing little and they're failing my exams. Okay, and I look at all your quizzes and they didn't come in at noon and redo any of them and you know, blah, blah, blah. Right? So, this unit here, you will see a huge disparity. You'll see lots of hundreds, and you'll see people, because it's either you don't half know this stuff. You don't even 3/4 know this stuff. Okay? Because if you 3/4 know it, you don't know it at all. You just won't get it right. You'll always have one couple little things wrong every time. So as you're going through this, I want you to even think, what would be on the quiz tomorrow? What would you ask, honestly, if you needed to know, if you're in my shoes, I needed to know they got the concept from yesterday. Which homework questions would you pick? Okay? I might not pick 6B because we did it together. Now I might even do 6C. I don't know, because I never did 6C with the other class, but I wanted to show you how quick it can be. Okay? Anyway, that's how you have to be thinking as you're going through this. Because I'm not only trying to teach you the math, I'm trying to teach you also how to play the game. Okay? Which is a big part of it. Okay, so we're doing 1 to 11.